Good evening, students. Today I am going to teach you guys Class 10 NCERT Chapter 1 Science, Chapter 1 Chemical Reactions and Equations. Consider the following situations of daily life and think what happens when milk is left at room temperature during summers. An iron tawa or pan or nail is left exposed to human atmosphere. Grapes get fermented. Food is cooked. Food gets digested in our body. We respire. So in all these conditions, there is some sort of changes occurring, right? So let's see in detail. In all the above situations, the nature and the identity of the initial substance have somewhat changed. We have already learnt about physical and chemical changes of matter in our previous classes. Whenever a chemical change occurs, we can say that a chemical reaction has taken place. So when we can say that a chemical change has been occurred, we can say that a chemical reaction has taken place, took place right there. So you may perhaps be wondering as to what is actually meant by a chemical reaction. How do we come to know that a chemical reaction has taken place? So how can we just tell or how can we know that whether a chemical reaction has taken place or not? For that understanding of the concept, we are going to perform some sort of activities and we are going to find out the answer for these questions. So first activity is activity 1.1. So while performing this activity, it should be taken into care that this activity needs the teacher's assistance. It would be better if students wear suitable eyeglasses. So first, what are the materials we are going to use are nothing but a magnesium ribbon, sandpaper, a pair of tongs to hold the magnesium ribbon, and we are going to burn this magnesium ribbon using a spirit lamp or burner, and we are going to collect the ash formed after burning the magnesium ribbon, which is we are going to take magnesium ribbon of about length 3 to 4 centimeter. So before burning the magnesium ribbon, we are just going to clean it with using a sandpaper. By rubbing sandpaper with magnesium ribbon, we are removing all sort of dust, and after that we are going to hold it with a pair of tongs, and after that we are going to burn it using a spirit lamp or burner, and we are collecting the ash formed after the burning action took place, and we are collecting the ash in a watch glass as you can see in this diagram, figure 1.1, that is burning of a magnesium ribbon in air and collection of magnesium oxide in a watch glass. That is, if you can see clearly, after burning, magnesium ribbon turns into ashes, right? What can we observe? We can observe that please note, students, that whenever burning takes place, always burning occurs due to the presence of oxygen in air. So we can simply write that magnesium, which is Mg, right, which reacts with O2 in air, we get MgO, which is nothing but magnesium oxide. But here the thing is, the equation is not balanced because here we have two molecules over oxygen. So I am multiplying here 2 to get balance, but here we get magnesium also twice, right? So here also I am multiplying with 2. Now this reaction is balanced. So this is the equation for this particular activity. This is the chemical equation. So in simple words, you can write that magnesium plus oxygen gives, that is 2 molecules of magnesium plus 2 molecules of oxygen gives 2 molecules of magnesium oxide. You must have observed that magnesium ribbon burns with a dazzling white flame. So we can observe, in the observation you might note down that magnesium ribbon burns. While burning, its flame color is white, which is very dazzling, and after burning the ash is nothing but it is a white powder. It changes into a white powder after it gets completely burnt. This powder is nothing but the magnesium oxide, which I just showed in the chemical equation form. It is formed due to the reaction between magnesium and oxygen present in the air. As I already said that magnesium, not only magnesium, any thing is burnt only in the presence of oxygen. Now let's move to activity 1.2. In activity 1.2, they are taking a lead nitrate solution in a test tube, adding potassium iodide solution to this. What do you observe? So if you see, when we take two metal solution, they definitely get reacted and they either form a new compound and they show some changes in their composition. In activity 1.3, they have mentioned that take a few zinc granules in a conical flask or a test tube. Add dilute hydrochloric acid or sulfuric acid to this. So as you see in this figure 1.2, we are taking first zinc granules, which is here at the top or at the bottom of this conical flask, and we are adding dilute HCl, that is hydrochloric acid, or we can add dilute H2SO4, that is dilute sulfuric acid, any one of the acid. And when both of these react, what happens? The thing is, we have to observe. Does there any change occur? Yes, formation of hydrogen gas by the action of dilute sulfuric acid with zinc, because we know that when a metal reacts with an acid, it would produce hydrogen gas. Please note this. So when the hydrogen gas is formed, definitely at the bottom of the conical flask or the test tube, we would feel the temperature change. So from the following all the 1.1, 1.2 and 1.3 activities, we can definitely say that any of the following observations help us to determine whether a chemical reaction has taken place or not. First is change in state. Second is change in color. Third is evolution of a gas. First is change in state, second is change in color, third is evolution of a gas, and fourth is change in temperature. If any one of the four takes place, we can definitely say that a chemical reaction has taken place. As we observe the changes around us, we can see that there is a large variety of chemical reaction taking place around us. We will study about the various types of chemical reactions and their symbolic representations in this chapter. Definitely. Now we are going to study about the different types of chemical reactions. And before that, we are going to understand what chemical equations are. So, the subtopic in this chapter is 1.1 chemical equations. So, in the activity 1.1, what we did, we took a magnesium ribbon and we have burnt it. So, when a magnesium ribbon is burnt in oxygen, as I already said, burning action takes place only in the presence of oxygen. So, when a magnesium ribbon is burnt in oxygen, it gets converted to magnesium oxide, and this is a description. And this description of a chemical reaction in a sentence form is really a long thing, right? So, hence we can write this in shorter form. So, simple way to do this is we can write it in the form of word equation. So, the word equation for the above reaction would be like magnesium plus oxygen gives, this arrow marks just show that there is some sort of chemical change undergoing in a reaction. Gives the product magnesium oxide. So here what are the reactants? Magnesium and oxygen are the reactants. And what is the product formed? The product formed is magnesium oxide. So the substances that undergo chemical change in the reaction, that is in the equation 1.1, are magnesium and oxygen, which are nothing but the reactants. And the new substance formed is magnesium oxide, which is formed during the reaction as a product. So this is a word equation which shows the change of reactants to products through an arrow placed between them. That is, these are reactants and this is the product, and this arrow indicates that these are the left to the arrow are reactants and to the right of the arrow is the product, right? So the LHS, in the LHS, that is in the left hand side, the reactants are written with a plus sign between them. Similarly, in case of there are more product, here only one product is formed, that is magnesium oxide. If in case there are many products formed, on the right hand side also there will be a plus sign between them. The arrowhead points towards the products and shows the direction of the reaction as well. So under this topic, now we are going to learn about how to write a chemical reaction. So the subheading is writing a chemical equation. So we have just now learned how to write a word equation. Now how to write a chemical equation? This is what we are going to learn in this subtopic. Is there any other shorter way or shorter form for representing chemical equations? Chemical equations can be made more concise, that is more useful and more precise if we use chemical formula instead of words, right? A chemical equation usually represents a chemical reaction. We know that. And we know that Mg is formula for magnesium, O2 is the formula for oxygen, and magnesium oxide, here it is already given in 1.2 equation as Mg capital O, which is magnesium oxide. So if you see, as I already shown you how to balance, we have to check whether it is balanced or not. How can we check that whether it is balanced or not? On the LHS, that is on the left hand side, that is on the reactants, and on the product side, both the number of both the sides, the number of atoms of each element must be equal. Otherwise the equation is not balanced. So if we see in the LHS, that is on the left hand side, for Mg it is 1. On the right hand side it is 1. On the left hand side for oxygen it is 2. But on the right side it is 1. So hence this equation is not balanced. So we have to balance this. So for that, what I am doing is, I am multiplying 2 on the right hand side. So 1 times 2 we get 2, right? For oxygen I am multiplying, hence I will get 2 MgO on the right hand side. But now when we multiply for oxygen, here we also get 2 Mg. So on the left hand side now we are having only 1 Mg. So now to get balanced, I am also multiplying 2 on the left hand side. So we get 2 Mg plus O2 will give 2 MgO. This would be the balanced equation. Please note down. And such a chemical equation is a skeletal chemical equation for a reaction, and the equation 1.2 is a skeletal chemical equation, whereas now which I have shown you guys is the balanced chemical equation, which we are going to study next. So next is 1.1.2 balanced chemical equations. We know that according to you guys have learned in class 9th itself that law of conservation of mass, that is, mass is neither can be created nor destroyed in a chemical reaction. That is, total mass of the elements present in the products of a chemical reaction has to be equal to the total mass of the elements present in the reactant side as well. So that means the number of atoms of each element should be the same before and after a chemical reaction. So hence in a skeletal chemical equation, if there is some unbalance in the chemical equation, we have to balance it. So here they have given the word equation for the activity 1.3 we have just studied. There we used zinc, that is Zn, plus sulfuric acid, that is H2SO4, which gives zinc sulfate, which is ZnSO4, plus hydrogen gas is evolved. So here on the left hand side, if we see, zinc has only one atom, and on the right hand side we have one atom. Here H2 we have 2, here also we have 2, so it is equal. 2 on the left hand side and 2 on the right hand side, number of atoms are equal. In case of sulfur, here it is 1 and here it is also 1. So sulfur is also equal. In case of oxygen, here it is 4. In the reactants also it is 4. So hence in reactants as well as product side it is equal. Hence this equation is already self-balanced. It is already balanced. Hence we have hence there is no need to balance it again. Now similarly we are going to try to balance the chemical equation Fe plus H2O, that is iron plus water, gives ferric oxide plus hydrogen gas is evolved. So here the given equation is Fe plus H2O gives Fe3O4 plus 4H2. Step 1. To balance a chemical equation, first we have to draw boxes around each of the formula. We should not change anything inside the boxes while balancing the equation. The step 2 is we have to list the number of atoms of different elements present in the unbalanced equation in a tabulated manner like this, given in the textbook. The step 3 is it is often convenient to start balancing with the compound that contains the maximum number of atoms. Over here in the we have to compare on both LHS and RHS. Here if we see oxygen O atom has the number of atoms with 4 as maximum in the product side. So hence initially we use oxygen and first balance for oxygen, and based on oxygen others also will get balanced. So for that initially there are 4 in the RHS, and hence we have to multiply by 4 in the LHS to get 4, because we are having, see initially we are having 1 in reactants and 4 in Fe3O4 for oxygen only. We are first balancing the oxygen atoms. So hence we are multiplying by 4 in the reactants to get 4. Now the overall equation becomes like this. That is Fe plus 4H2O gives Fe3O4 plus H2. Now the equation is partly balanced. Now moving to the step 4. But since the equation is only balanced for oxygen, moving on to the step 4. In step 4 we can see very well that iron and hydrogen atoms are not still balanced. Hence we have to pick any of these elements to proceed further. So first we are taking hydrogen atoms in the partly balanced equation, that is equation 1.6. Now when we consider hydrogen atoms in the reactant side, initially there are 8 in 4H2O, 8 hydrogen atoms in reactants, and in products only 2 are there. Hence to balance we can multiply 4 to 2 in the product side to get the equation. Now the equation would be Fe plus 4 times H2O gives Fe3O4 plus 4 times H2. This equation, let's say it is 1.7, which is a partly balanced equation. Now step 5 is nothing but to examine the above equation. That is, now we are only left with the checking part. So that is, initially we are having that the third element which is not balanced. That is, we have first balanced oxygen, then second we have this note, first initially we balanced oxygen atoms, secondly we balanced hydrogen atoms, and hence the leftover is only iron. So we have to balance iron part as well. In reactants we have now only 1, whereas in product side there are 3 atoms in Fe3O4. So hence we have to multiply in reactants by 3 to get 3, which is 1 times 3 So now after balancing we get the equation 1.8, that is 3 times Fe plus 4H2O gives Fe3O4 plus 4H2. Now the next step is step 6. Finally we have to check the correctness of the balanced equation. To check the correctness of the balanced equation, we have to count the atoms of each element on both sides of the equation, that is on the reactant sides as well as on the product side. So in the reactant side, for iron it is 3 atoms, and so we also have Fe3O4, in which we have 3 atoms in the product side for iron as well. In reactant side, in 4H2O we have 4 atoms of H2 molecule, and similarly we have 4H2 in the product side. Hence there are 4H2 molecules on both the sides. Hence for hydrogen also it is balanced. And there are 4 oxygen atoms in the reactant side as well as in the product side. Hence the total equation is balanced. This method of balancing chemical equation is called hit and trial method, as we make trials to balance the equation by using the smallest whole number coefficient possible. Now the step 7 is writing symbols of physical states. If we see here the balanced equation, to make a chemical equation more informative, the physical states of the reaction of the reactants and products are mentioned along with their chemical formulae, that is whether they are gaseous, liquid, aqueous state or solid states of reactants and products. They are represented by the notation G, L, AQ for aqueous and S for solid respectively. The word aqueous, AQ, is written if the reactant or product is present as a solution in water. Hence the balanced equation 1.9 over here, right? We can write this equation as 3FeS, which is where Fe refers to iron, which is a solid, and 4H2O is water is in gaseous state, Fe3O4 that is ferric oxide, which is a solid substance, and 4H2 refers to hydrogen gas evolved, which is represented by G. Notice that the symbol G is used with H2O because the water here in this reaction used is in the form of a steam. And so we can also say that usually physical states are not included in a chemical equation unless it is necessary to specify them. Sometimes the reaction conditions such as temperature, pressure, catalyst, etc. for the reaction are indicated above and or below the arrow in the equation. For example, here they have given 2 equations. First is carbon monoxide CO, which is in gaseous form, plus when reacted with hydrogen gas gives CH3OH, which is a liquid, that is in presence of 340 atm refers to atmospheric pressure. Then in the second equation, that is 1.12, 6CO2 aqueous, that is carbon dioxide in aqueous form, when reacted with 12 molecules of H2O, which is in liquid form, that is water itself, in presence of sunlight and chlorophyll, gives glucose, that is C6H12O6, which is in aqueous form, and 6 O2 molecules and 6 H2O molecules are produced along with glucose. Now using these steps, can we balance equation 1.2 given in the text earlier? Equation 1.2 is nothing but in the beginning of this chapter we have read an experiment that when magnesium reacted with oxygen will give MgO. This was the thing. We know that magnesium is a solid, so we have to write S, plus O2 is gas. So we have to write gas. G for gas gives 2 molecules of MgO. So this is the exact balanced equation for the equation 1.2 given in the previous table of exercise in the previous experiment we have performed. Moving on, the topic 1.2 is types of chemical reactions. We have learned in class 9 that during a chemical reaction, atoms of one element do not change into those of another element, nor do atoms disappear from the mixture or appear elsewhere. Actually, the chemical reaction involves the breaking and making of bonds between atoms to produce new substances. The difference between chemical change and physical change is that in case of physical change, there is only physically a substance has been changed into its form, which is reversible change. Whereas in case of chemical reaction, due to a chemical reaction, a new substance itself gets formed from the reactants used. You will study about types of bonds formed between atoms in chapters 3 and 4. So, under the types of chemical reaction, the first type of chemical reaction is 1.2.1 given as combination reaction. To understand this combination reaction, let us perform some activity 1.4 given here. So here they have given that take a small amount of calcium oxide or quicklime in a beaker, slowly add water to this and then touch the beaker as shown in the figure 1.3. Do you feel any change in temperature? So we are taking a beaker, adding calcium oxide, which is nothing but quicklime. After that, we have to slowly add water to this, and after adding, we have to touch the beaker and see whether there is a change in temperature or not. So the output, the observation is nothing but calcium oxide reacts vigorously with water to produce slaked lime, which is nothing but calcium hydroxide. Slaked lime is the general name, whereas the chemical name for slaked lime is calcium hydroxide. And producing calcium hydroxide, along with that, it releases a large amount of heat as well. So the chemical equation for this particular activity can be written as given here. First is CaO, that is calcium oxide, which is a solid. Hence we are putting S in brackets. Quicklime, that is its general name, is written below, plus when reacted with water, it is in normal liquid form, that hence we can write as H2OL gives, which represents the arrow. Products would be calcium hydroxide, that is CaOH twice. This calcium hydroxide is neither completely liquid, neither solid. It is in a solution form. It is in aqueous state, and hence we are writing AQ in bracket. Its general name is slaked lime, which we write it below the equation. Plus heat is released. In this reaction, calcium oxide and water combine to form a single product, that is calcium hydroxide. That is a reaction, such a reaction in which a single product is formed from two or more reactants is known as a combination reaction. That is, what if you guys would do that if you are asked to define a combination reaction? You should write the answer would be a reaction in which a single product is formed from two or more reactants is known as a combination reaction. And if they ask for any example, you can write the example of calcium oxide reacting with water to give calcium hydroxide along with some amount of heat produced. Now there is an interesting fact given by the table. Do you know? From this equation of the reaction mentioned as 1.13, just now we have studied about the calcium oxide reacting with water. A solution of slaked lime, that is CaOH twice, is produced, right? This slaked lime solution is used for whitewashing walls, it seems. Calcium hydroxide reacts slowly with carbon dioxide in air to form a thin layer of calcium carbonate on the walls. That is, CaOH twice, which is in aqueous state, reacts with carbon dioxide in its gaseous form to give CaCO3, which is calcium carbonate, which is a solid, and also gives some water, H2O, in liquid form. Calcium carbonate is formed after 2 or 3 days of whitewashing and gives a shiny finish to the walls. And it is very interesting to note that the chemical formula for marble is also CaCO3. Hence, don't confuse with both these terms. Both are having the same formula. Now, let us discuss some more examples of combination reactions itself. So, first example would be burning of coal. Coal is nothing but carbon in its natural state, in its solid state. So, when coal is burnt, so burning always occurs in presence of oxygen. So, C plus O2, that is oxygen in gaseous state, will give carbon dioxide, CO2, which is also a gas, which is nothing but equation 1.15. So similarly, formation of water from molecules of hydrogen and molecules of oxygen, we get 2H2 gas, which is a gas, plus O2, which is also a gas, gives 2 molecules of H2O, which is a liquid, which is nothing but water. That is, to simply say, 2 molecules of hydrogen when reacted with 1 molecule of oxygen gives 2 molecules of water. So, simply we can say that when 2 or more substances, that is, it can be either elements or compounds, when they react and combine to form a single product, that is, in the product side only one single product is formed, then the reactions are called as combination reaction. In activity 1.4, we also observed that a large amount of heat is evolved, and hence we can say that the heat evolved makes the reaction mixture warm as well. So, these type of reactions, that is reactions in which heat is released along with the formation of products, are nothing but are called as exothermic chemical reactions. So first we have studied about combination reaction. Now we are studying exothermic reaction, exothermic chemical reaction. Now, other examples of exothermic reactions are One would be burning of natural gas. Natural gas, in sense here we are taking CH4. CH4 is the chemical formula for methane. So CH4, that is methane gas, when burning always takes place in the presence of oxygen. That is, when reacted with O2, I will balance in the last. So we would get CO2, that is carbon and O2 molecule combined, giving carbon dioxide, and we have 2H2O. So carbon dioxide is a gas and 2H2O is also a gas here. So this is also an example for, so we can say that CH4 plus 2O2 would give CO2, which is in gaseous state, plus 2H2O, which is in gaseous state. We can also say that respiration is also an exothermic process. Why? Because also in respiration, during when we respire, heat energy is released. We all know that we need energy to stay alive. We get this energy from the food we eat. During digestion, food is broken down into simpler substances. For example, the food we eat would be rice, potatoes, vegetables, bread, and all these things contain carbohydrates. These carbohydrates are broken down to form glucose. This glucose combines with oxygen in the cells of our body and provides energy. The special name of this reaction is nothing but the respiration, and hence respiration is an exothermic process. Now here we have we can write the reaction of, it is the chemical reaction which occurs in respiration. Glucose is formed, right? Glucose, when acted with oxygen, we get carbon dioxide released and some water and some energy is released. We know that C6H12O6 is the chemical formula for glucose. Glucose is always in its aqueous state in blood, right? It is in solution form. When reacted with oxygen inside our body, which is also in aqueous state, would give 6 molecules of carbon dioxide, which would also be in aqueous state. There is no other way. Plus some water. 6 molecules of water is released in the liquid form itself, and some energy is released. Always remember, students, when energy is released, it is definitely indicating that the equation is the representation of an exothermic reaction. Moving on, the third example is the decomposition of vegetable matter into compost is also an example of an exothermic reaction. Identify the type of the reaction taking place in activity 1.1, where heat is given out along with the formation of a single product. Okay. If we see that in equation, in the activity 1.1, magnesium reacts with oxygen to give magnesium oxide, and hence only one product is formed. That is, many reactants react to produce a single product. Hence, this is an example of what? Combination reaction. Moving on, the second type of chemical reaction is 1.2.2, which is given as decomposition reaction. Let us perform activity 1.5 to get to know about decomposition reaction in detail. So we have to take about 2 grams of ferrous sulfate crystals in a dry boiling tube. Note that the color of the ferrous sulfate crystals would be in bluish color. Heat the boiling tube over the flame of a burner or spirit lamp as shown in figure 1.4. Here a student is wearing a lab coat and is in a lab. She is holding holding the dry boiling tube with ferrous sulfate crystals in it, and she is heating using a spirit lamp. Have you noticed that the green color of the ferrous sulfate crystals has changed? So initially the ferrous sulfate crystals would be in green color. After the heating, we can say that it would produce some sort of odor like burning sulfur. So 2FeSO4, that is ferrous sulfate, when heated would give ferric oxide, that is Fe2O3. Fe3O4, that is ferrous oxide. Fe2O3 is ferric oxide, please note. So it gives Fe2O3, which is a solid, plus sulfur dioxide, which is in gaseous state. Along with that, it gives sulfur trioxide, which is SO3. In this reaction, you can observe that a single reactant, that is FeSO4, breaks down to give simpler products, whereas in the combination reaction, 2 or more products combine to give one singular product. One single product is obtained after reaction, whereas here one single product is reacted and gives many products. Ferrous sulfate crystals, that is FeSO4 7H2O, is actually nothing but loose water when heated, and the color of the crystal also changes, and hence it decomposes into ferric oxide Fe2O3, sulfur dioxide SO2, and sulfur trioxide. And this ferric oxide is a solid, whereas SO2 and SO3 are gases as mentioned in the equation itself. Decomposition of calcium carbonate to calcium oxide and carbon dioxide on heating is an important decomposition reaction used in various industries, because these type of reactions are very useful for industry people, because calcium oxide, which is either called lime or quicklime, this is used in the manufacture of cement. So we can say that when this decomposition reaction is carried out in the presence of heat or by heating, this process would be called as thermal decomposition, that is CaCO3, that is limestone, which is in solid state, when heated gives quicklime, that is calcium oxide plus carbon dioxide is evolved. Another example of a thermal decomposition reaction is given by the next activity, which is activity 1.6. Over here we are taking about 2 grams of lead nitrate powder in a boiling tube, and hold the boiling tube with a pair of tongs and heat it over a flame as shown in figure 1.5 over here. So after heating it, what can we observe? We should note the change if there is any. We can see that there is some emission of brown fumes. These fumes are nothing but nitrogen dioxide, that is NO2. The reaction that takes place is nothing but lead nitrate, that is 2Pb NO3 twice, which is a solid, when reacted with heat decomposes as lead oxide, 2PbO, which is a solid, lead oxide is a solid, along with nitrogen dioxide gas, and oxygen is released. Now let us explore and perform some more decomposition reactions as given in activity 1.7 and 1.8. So we are first in activity 7, we are first taking a plastic mug, and inside that mug we are drilling 2 holes at its base and fixing rubber stoppers in these holes, and after that we are inserting carbon electrodes in these rubber stoppers as shown in 1.6 figure. Now after that we are connecting the electrodes to a 6-volt battery. After that we are filling the mug with water such that the electrodes are immersed. After that we are adding a few drops of dilute sulfuric acid to the water, and now we have to take 2 test tubes filled with water and invert them over the 2 carbon electrodes. After that we have to switch on the current and leave the apparatus undisturbed for some time. After some time you can observe that there is some formation of bubbles at both the electrodes. These bubbles displace the water in the test tubes. There would be some sort of displacement in the water. So is the volume of the gas collected the same in both the test tubes? You have to make a note. After that, once the test tubes are filled with the respective gases, remove them carefully and test these gases one by one by bringing a burning candle close to the mouth of the test tubes. Please note that this activity should be performed with the help of a teacher. And please note what happens in each case and which gas is present in each test tube. In activity 1.8, we are taking 2 grams of silver chloride in a china dish. So initially note what is its color, and after some time, so first we are taking 2 grams of silver chloride and we have to note its color. After that we have to place this china dish in sunlight for some time. After that note the color of the silver chloride. So in activity 1.8 we can say that the silver chloride the color which is initially normal would turn grey after placing in presence of sunlight. This is because the silver chloride decomposes into silver and chlorine, that is AgCl, which is solid, decomposes to Ag plus Cl2. So here when we balance we get 2AgCl2 plus gives 2Ag plus Cl2, in which Cl2 is gas and Ag is solid. And similarly silver bromide AgBr, 2AgBr, which is also a solid, in presence of sunlight would also behave in the similar manner, which would give 2 Ag molecules, which is solid, plus Br2, bromine is evolved in the form of gas. And the above reactions are used in black and white photography. Please note this is then application of the reactions. What form of energy is causing these decomposition reactions? We have seen that the decomposition reactions require energy either in the form of heat, light or electricity for breaking down the reactants. So note that either in form of heat or light or electricity, there is energy required to decompose. So previously we learned that what is exothermic reactions. Now we are going to study about the definition of endothermic reaction. So what is endothermic reactions? So reactions in which energy is absorbed are known as endothermic reactions. This is just opposite to exothermic reactions. Carry out the following activity. Take about 2 grams of barium hydroxide in a test tube and add 1 gram of ammonium chloride and mix with the help of a glass rod. Touch the bottom of the test tube with your palm. What do you feel? Is this an exothermic or an endothermic reaction? Definitely it would be an endothermic, I think it would be endothermic only, because we would not feel much amount of heat released, even though if it is released. So I would be separately giving you the answers for the in-text questions as well as the exercise questions in a separate video after completing the chapter. So let me skip it. So next topic is 1.2.3 displacement reaction, activity 1.9. Take 3 iron nails and clean them by rubbing with sandpaper. Take 2 test tubes marked as A and B, and in each test tube we have to take about 10 ml of copper sulfate solution. Tie 2 iron nails with a thread and immerse them carefully in the copper sulfate solution in test tube B about for 20 minutes and keep one nail aside for comparison. After 20 minutes, take out the iron nails from the copper sulfate solution. After that, we have to compare the intensity of the blue color of copper sulfate solutions in test tubes A and B. If we see in figure 1.8a, here they have shown that iron nails are dipped in copper sulfate solution. Now here in 1.8b, iron nails, one is normal one and another one would be iron nail taken out from the copper sulfate solution. The iron is copper from copper sulfate is getting displaced and copper is deposited on the iron nail, and hence the color of the nail is turned to be brown, right? Here they have asked a question, why does the iron nail become brownish in color and the blue color of the copper sulfate solution fades? Because when iron reacted with copper sulfate solution, iron is having more iron reacts very well. So when iron reacts with the copper sulfate, it forms ferrous sulfate, that is iron sulfate, and displaces copper, and hence copper deposits on the nail. In this reaction, iron has displaced or removed another element, that is here the another element which is getting removed is copper from the copper sulfate solution. This reaction is known as displacement reaction. That is, one element is removing another element from its solution itself. Other examples of displacement reactions would be zinc. When it is in solid state, it is naturally a metal, it would be in solid state. When reacted with copper sulfate gives zinc sulfate along with copper deposits are formed. And similarly, lead, which is a metal which is in solid state, when reacted with copper chloride, which is an aqueous solution, gives lead chloride, and copper chloride, copper chloride, copper is getting displaced, and hence we can definitely say that zinc and lead are more reactive elements than copper, and hence they displace copper from its compounds. The next type of reaction is double displacement reaction 1.2.4. So to understand double displacement reaction, we are going to perform activity 1.10. We are going to take about 3 ml of sodium sulfate, which is Na2SO4, solution in a test tube, and hence its state is aqueous. In one test tube we would be taking this. In another test tube, take about 3 ml of barium chloride solution, BaCl2, which is also in its aqueous state. Now next we are going to mix the two solutions as shown in figure 1.9. What would you observe? What do you observe? You will observe that a white substance which is insoluble in water is formed, and this insoluble substance is known as a precipitate. Any reaction that produces a precipitate can be called as a precipitation reaction. So hence we can, how would we define what is a precipitation reaction? Any reaction that produces a precipitate can be called as a precipitation reaction. Here we are taking sodium sulfate Na2SO4 in its aqueous state, that is in solution form, when reacted with BaCl2, barium chloride, in its aqueous forms, gives products as barium sulfate, which is solid, along with 2 molecules of sodium chloride in its aqueous solution. Now what causes this to happen? The white precipitate of the barium sulfate, that is BaSO4, is formed by the reaction of SA4. So here the white precipitate of barium sulfate is formed by the reaction of SA4 minus and Ba2 plus, that is the oppositely charged ions. The other product formed is sodium chloride, which remains in the solution. Such reactions in which there is an exchange of ions between the reactants are called double displacement reactions, because here there is displacement of metals as well as exchange of ions taking place. So what is the next definition? Next type of chemical reaction which we have studied is double displacement reaction, and the definition for this would be reactions in which there is an exchange of ions between the reactants are called double displacement reactions. Recall activity 1.2, where you have mixed the solutions of lead 2 nitrate and potassium iodide. What was the color of the precipitate formed? Can you name the compound precipitated? So in activity 1.2, you just note what are the things. Just note what are the observations of activity 1.2 and check for all these questions. The second question is we have to write the balanced chemical equation for this reaction, and third one, whether we have to say whether it is a double displacement reaction or not. So next type of chemical reaction is 1.2.5, oxidation and reduction. Here from the name itself you can say here oxidation and reduction. There are two types of reaction taking place, but it is given in the same as a one phrase word. Why it is so? Let us find out. Activity 1.11. Heat a china dish containing about 1 gram of copper powder as given in figure 1.10. What do you observe? When the copper powder is heated, using when it is placed in a china dish. The copper oxide is formed when copper is heated. And this is because oxygen when is always present while burning, right? So this is because oxygen is added to copper, and hence when the equation for the reaction is given by equation 1.28. That is when two molecules of Cu, that is copper, reacts with two molecules of O2, that is oxygen. In presence of heat, we get 2CO, that is copper oxide. Now, if hydrogen gas is passed over this heated material, that is copper oxide, the black coating on the surface turns brown as the reverse reaction takes place, that is copper oxide plus hydrogen. In presence of it would give copper plus water, which is given by equation 1.29. Now, we can say that if a substance gains oxygen during a reaction, it is said to be oxidized. And similarly, if a substance loses oxygen during a reaction, it is said to be reduced. Now, in the equation 1.29, when the reaction is taking place between copper oxide and hydrogen, in this we can say that the copper 2 oxide is losing oxygen and thus it is being reduced. The hydrogen is gaining oxygen and is being oxidized. In other words, one reactant gets oxidized while the another one other than the that which is getting oxidized, the other one would get reduced during a reaction. And such reactions are called as oxidation reduction reactions or redox reactions. Over here, if we draw arrows and mention, we can say that copper oxide when reacted with H2, that is hydrogen gas, would give copper, that is copper oxide is reduced to copper, that is a reduction has taken place, whereas hydrogen in presence of heat gives rise to H2O, that is water, that is addition of oxygen has taken place, that is oxidation has taken place. Some other examples of redox reactions would be zinc oxide when reacted with carbon would give zinc plus carbon monoxide. Similarly, manganese oxide plus 4HCl, that is hydrochloric acid, would give rise to manganese chloride plus water plus chlorine, which is represented by the equation 1.32. Now, in reaction 1.3.1, that is which is given by equation 1.3.1, that is zinc oxide when reacted with carbon would give zinc plus carbon monoxide. In this reaction, we can see that carbon is oxidized to carbon monoxide and zinc oxide is reduced to zinc itself. And similarly, in this equation 1.32 given here, we can say that HCl is oxidized to chlorine, whereas manganese oxide is reduced to manganese chloride. From the above examples, we can easily say that we can conclude that if a substance gains oxygen or loses hydrogen during a reaction, it is oxidized. That is, gains O2 or loses H2. This means it is oxidized, or else loses O2, that is loses oxygen, gains H2. This second set means reduction, that is some a substance is getting reduced. Recall activity 1.1, where a magnesium ribbon burns with dazzling flame in air, oxygen, and changes into a white substance, that is magnesium oxide. Is magnesium oxide being oxidized or reduced in this reaction? Definitely, magnesium oxide is getting oxidized because oxygen is added to magnesium. Hence, it is an oxidation reaction. Now, last topic in this chapter 1.3. Have you observed the effects of oxidation reactions in everyday life? In this, the effects of oxidation reaction is two things in everyday life. One is corrosion, the second is rancidity. 1.3.1 corrosion. You must have observed that at iron articles, which are very shiny when new, but soon they get coated with some reddish brown powder when left for some time. This is commonly called as rusting of iron. This process is called as rusting of iron. So this is the definition for rusting of iron. And also some other metals also get tarnished in the same particular manner. Similarly, we can see that there is coating formed on copper or silver. When a metal is attacked by substances around it, such as moisture, acids, etc., it is said to corrode, and this process is called corrosion. So what is corrosion? When a metal is attacked by substances around it, like factors like moisture, acids, bases, they tend to change the nature of the metal itself. So hence it is said to corrode, and this process is called corrosion. The black coating on silver and the green coating on copper are the examples of corrosion. Corrosion causes damages to car bodies, bridges, iron railings, ships, and to all objects made of metals, especially for those of iron. And hence corrosion of iron is also a serious problem, because every year a huge amount of money is spent to replace the damaged iron. For example, the railway bridges we see across through get damaged every year, which are made up of iron. They are getting replaced by huge expenses. And next, the last topic in this chapter 1.3.2, rancidity. Have you ever tasted or smelled the fat or oil containing food materials left for a long time? When fats, if you see, we can easily identify that whether an food item which we used to consume regularly has got spoiled or not by the smell, by the odor coming from it. So when fats and oils are getting oxidized, they become rancid and they smell and taste change. Usually, substances which prevent oxidation, that is antioxidants, are added to foods containing fats and oil. And keeping food in airtight containers helps us to slow down oxidation. So, and now you can understand that why chips manufacturer usually flush bags of chips, that is like Lay's, Kurkure, all these chips packets, they are usually contain some air in it, right, with some gas. So like nitrogen, why they are using it? To prevent the chips from getting oxidized, to get spoiled. And hence this is the end of our chapter. I will be posting a separate video in which I would be solving the in-text questions and the exercise questions of this chapter. Thank you, students. I hope the video is very informative. If you really like the video, please like, share and subscribe to my channel Learn with Indra Lakshmi.